The first step will be to set up the various loads and material properties. First, I want to discuss our posts. These are embedded into the fill and through the structural concrete ramp into a circular blockout of 15 centimeters in diameter. You can see magenta here. The post will rise a maximum of 110 centimeters above the ramp, and they'll be embedded a minimum of 40 centimeters below the structural concrete with a 15 centimeter width blockout. In blue, you can see they'll be spaced at a maximum of 200 centimeters. In the actual value of the material we're using for the post will be a minimum 40 schedule 30 pipe embedded with a fine grout. Filled with a fine grout. The schedule has to do with the thickness of the walls. So this would also be an NPS 1.5 inch schedule 30, which has an actual dimensions of 1.9 inches by 1/8 inch thick. Note this is the minimum. What is likely you'll find in practice is a 1.5 inch standard pipe, which actually matches the AISC HSS pipe detail of 1.9 inch diameter by 0.145 inches thick. So the difference here is the thickness. Again, it's 0.145 inches thick instead of what is specified, which is the minimum, which is 0.125 inches thick. So we'll go through the calculations using this standard size wall thickness pipe because all of our values will be easier to find and easier to track in the AISC. Now the cable is going to be attached to the post and secured by eye bolts at the final post. The eye bolts, cable size, and clamps depend on availability and procurement in country and should be chosen based off the two tables provided, the schedules provided in the detail. Fencing is attached to the cables and the posts with tie wire and should be an 11 gauge chain link with a maximum of 2 inch spacing. The weight of this fence we can read off charts that I'll attach below of approximately 1/2 pounds per square foot. And this will be a pretty common material that you'll find in country, so you won't need to worry too much about having different types of fencing. Like I mentioned before, Schedule 40 is more common, the 40 Schedule 40, which is also the standard pipe size for wall thickness. So I have listed all of the information for a 40 Schedule 40 pipe here. Its weight, its section modulus, plastic section modulus, and we'll be using a specified steel yield strength of 50 KSI. Now, the last thing I want to discuss in this lecture is the different loadings on the fence post. So we'll have our dead load, which is in the axial direction of the post, and this is going to be the summation of the fence weight, the cable weight, grout fill, and the fence self weight. Remember, this fence post is filled with grout as well at the end. Our live loads we can get from a few sources, but we'll use the IBC section 1607.8 with loads on handrails, guardrails, etc., which requires to resist a linear load of 50 pounds per linear foot on the supports and 200 pounds anywhere, a concentrated 200-pound load anywhere on the post. However, we can take exception 1 for single or two dwelling families, which says you only need to take a single 200-pound load that can be placed anywhere on the post. Now, we take this exception, we take this reduction because of how low risk and how low traffic our use case actually is. So we'll take that 200 pounds anywhere instead of our combination of our 50 PLF between supports. And additionally, we read that we need to design our infill components, so our fence and our tie wires, etc., to resist a 50-pound infill load. In the combination of our live load and dead load, we'll use the ASC load combinations, and as well as our wind load, we'll use the ASC 710 procedure to define our wind load on the fencing.